Great. Well, welcome to session 3 of Basecamp 11. Today, the focus is going to be on how to test smart contracts. We're going to be building upon the work that Okai did last week. So we're basically Thomas is going to show you how to write the smart contracts for this counter smart contract that Okai created. And before we get into the session itself, let me talk about the hackathon that is coming up for Starknet, which is going to be a great place for you guys to put into practice what you've learned. So it's called the Winter Hackathon. It's going to be over 2 action-packed weeks. Uh, so it's going to start January 6th until January 19th. You can register even today. We're going to have 5 different tracks, all of them in on a Starknet. But one is for gaming, one for AI agents, one for Telegram applications, community, and DeFi. And that's the link. I'm just gonna drop the link to the slides on the chat, even though I share them on Discord slides, just for you to have the link to register to the hackathon. So that's it, the hackathon. And as I mentioned, this is part of a journey that is started with Basecamp, continues with the hackathon. Then we're gonna have the Hacker House at Denver in February. And the idea is that you keep working on your project to the point that you will be ready to actually for the foundation to support you financially so you can go to the next level. That's called the seed funding. Uh, and then you can do seed funding. There's gonna be a demo day, May, that's new, May 2025, and then fundraising. So it's a journey from learning to building to launching, and we're gonna support you along the way. A little recap from session 1 and 2 to remind ourselves what we have done so far. So in session 1, we discussed some of the fundamentals about why Cairo, why Starknet, what does it make it unique, how does it make it scale. We talk a bit about ZK Starks and ZK Snarks. We focus a lot more on smart wallets. We talk about what makes them special, how do they work. We actually created one for mainnet, one for testnet. Then I show you how to set up your dev environment using the Docker image that we created. And then in session 2, Okai show you how to create a smart contract from scratch, where you can increment the counter, decrement, reset the counter. But it also added the owner component, so you know how to basically use building blocks to improve the capabilities of your smart contract. And that component was coming from Open Zeppelin, so we show you how to integrate the dependency. And then Okai also show you how to deploy that smart contract to testnet using Starknet, which Starknet being the CLI for Starknet. So that's the recap so far. And now I'm going to hand it over to Thomas to talk about what we're going to be talking today in this session.
Hey everybody. Yeah, so today we're going to be talking about testing. Testing is very, very important. I know Nico, I know you put in a message about how everybody needs to learn testing before coding. It's development strategy. Definitely agree with that. That's very, very important. So we're going to start with fundamentals, some simple smart contracts, and then we'll move on. I think David, if you want to advance the slide. Yeah. So we're gonna intro the tool, Starknet Foundry. We'll do some basic tests, some really simple happy paths, and then we'll talk about a little bit more advanced topics.
Recall that at the end, we're going to have a quiz like every session, just 5 questions. So please stay until the end. I'm going to stop sharing my screen, Thomas, so you can take over and share yours.
Yes, one second. Let me pull up. Okay. All right. Can everybody see my screen? How's
Yeah, I
the?
can. If you can increase the font size a little bit more.
All right. Yes. About to ask. How's that?
Yeah, perfect.
All right. So let's jump right in. So the first thing I want to talk about is Starknet Forge or Starknet Foundry, and the SynForge STD dependency that we're going to be using. So right now we have it installed from GitHub. This is how they used to recommend to do in the docs, but as we learned last session, what we can use actually is the scarb uh, package registry. So if we look in here,
Screen the font size for that one, please.
yes, we can also see that they have this package. So we don't need to go from GitHub. We can actually change this just to 0.34.0. Awesome. And this will download from Scarb. And that's the recommended approach for getting our dependency. All right. So if we got that going, let's jump in. All right. So we're gonna need a bunch of dependencies. I'm just gonna go to my cheat sheet here and grab these, and we'll talk about them as they're used. Okay. So first things first, we need to deploy the contract. So to deploy the contract, we're going to be using declare to declare the contract class and then the contract class trait and the declare result trait. Um, so our first test, which we define with the test macro, let's just call test deploy contract. So this is just going to deploy the contract, and then we can look at our constructor to see what we want to verify as we deploy it. So if we look at our constructor here, we see that we write this initial value. So I think a good place to start is to deploy the contract and then make sure that our initial value is set. So let's do that. To deploy the contract, we first need to declare it. And counter is the name of our contract here. You can see that there. It's the name of our module. Just unwrap this. Okay. So next thing we need to do is we need to serialize the call data. So when we're creating when we're passing args to the constructor, we actually need to serialize that data. We can't just pass it in directly. So to do that, let's create a variable call data. And we're going to use the array macro. And then we're going to need an initial count. So the initial count, um, we can just set here. Just start it at 0. And now we're going to need to serialize this variable in order to pass it into the array. So let's do that. So we're going to serialize this, give it the reference to the call data array, so it'll serialize it into that array. And the next thing we need when we look at our constructor is this initial owner, which is a contract address. So when we're testing, a really easy way to just get a contract address is going to be to just create it from a string. So we can do that like this. So we can say owner, we can get a new function for owner. You notice I'm not using the test macro here. This is just going to be a function that's going to be used by our tests, but in and of itself is not a test. So this is going to return a contract address. And we can just call this owner. So we're just going to turn this string into some data that looks like a contract address. Awesome. So this is what we can use for our contract address. So let's go ahead and go in here and
Could you explain how come we're using something that looks like a string instead of an actual address, and why does it work?
yeah. So we just need a hexadecimal value that looks like a contract address. We don't need a whole actual account. So this is a way to simply um, define some different contract addresses we use. Because we're using this string, it's when we convert this to a contract address, it's going to be unique. So we could do something like owner two, and now we have two unique contract addresses. So this is just a really simple way to get a contract address that we can use for testing.
Yeah, it's like a testing technique, but it works. Basically, a short string can represent an address in hexadecimal or something that is based on ASCII.
So let's serialize this as well. Awesome. So this is the call data that we're going to be passing into our constructor.
What does it mean to serialize?
To convert it to binary, where well, basically let's look at the serialize function. So what this function does is right here. So this is going to take this data that we have defined as a U32, and we're going to convert it into a sequence of felt 252 type. So we can see an example of that here. Okay. So now we're going to actually deploy. You have this call data. Oh, okay, so this is what is going to actually deploy our contract. And if we look at the deploy function, we already declared the contract class with declare here. Um, the constructor call data is what we passed in. We can see that this returns a contract address um, and the constructor return data, but we're not worrying about that right now. So we can just use this underscore to disregard it. Great.
Does it need to be always underscore?
I believe so. Um, we could assign it to a variable and then just not use the variable. But the underscore indicates to Cairo that we know that there's a variable there that we're just not going to use.
Yeah, I think it's only that convention.
Um, great. So we deploy this contract. Let's see what happens if we run our test right now. Oh, on running the tests. So if we look at our scarb.toml, we see our script here test. So when we run scarb test, we can actually override what the default is. Um, and we're going to override that with the actual Starknet Foundry testing command. So when I run scarb test here, it's actually running this command synforge test, um, which you can do this. You can do help on the command to see a little bit more information about all the options you have for running tests. Some really good ones are things like detailed resources, so you can get more information about what's happening inside the contract as the tests are running. So let's go ahead and run the tests. And we can see the command that is running there as well. Okay, so we have some errors. Let's look at their errors.
Before we
Counter is,
move on, Roman is asking which extension make the control click on a method that opened the source code?
oh, um, this is in the container. It's just the I believe the dev container.
Think it's the Cairo extension on the IDE. It just gives you
Yes. So it's this one.
language cover. Yeah, language support.
Yeah. So this extension is included. It gives you the language server. I'm using them. So to uh, make this a little bit more clear, what we can do is you can also just right click and hit go to definition. And that's what I'm doing.
Yeah, on VS Code, if you have the Car1 extension, you will be able to do that as well.
Yeah. If you're running in the dev container, you do have that extension. Sometimes it dies. If it dies, an easy thing to do is you can just reload your workspace. You can run this, and it'll restart it. Okay. So we see the counter is not visible in this context. So when we're testing, we need to add, we need these to be public. So where's the counter? I forget if it's here it is. So this isn't public right now. So let's go ahead and add public to that so that we can see that um, value. And we can see that these also are not visible. And for those guys, we need the interface. Okay, so we added public to our counter and we added public to our counter interface. And we can see that in here. Now it's just yelling at us because they're not being used. Okay, let's go ahead and run this again. Oh, and if you do use Vim, you can just use GD, which is go to definition. Okay, so this function passed, or this test passed, which is awesome. So we know our contract is getting deployed, but we don't really know anything about that deployment. So what is we can uh, we can set up something called a dispatcher. So dispatchers are what is going to let us interact with the contract. So these are generated from the interface, and we can just use them from the contract. So let's set up our first dispatcher. Oops.
I have a question. When you deploy the smart contract, where are you deploying it? To mainnet, to testnet, to devnet?
That's a good question. I think it's just the Starknet Foundry runner. Um, I'm not actually sure where it's going. Um, but we can
Yeah,
look at
it has its own emulator, Starknet Foundry.
yeah, okay. Yeah. And you can look at the docs to get more information about that.
Sandra's asking, could you repeat what is the dispatcher?
Yeah, so the dispatcher is what's going to let us interact with smart contracts. So let's talk about the first dispatcher. Mm, well, the docs aren't extremely explicit about what it is, but the dispatcher is what's going to let us interact with the contract. So we set it up like this, and now we have a dispatcher that we can use to interact with our contract. Okay, so we want to get our current count that we initialized here. So what we want to do is we want to call get counter and get that count, and make sure it actually is the variable that we initialized it with. So let's create a variable called current counter. And we can see that we have the get counter function. So let's call this. And now the next thing we want to do is we want to write an assert. So we're going to write an assert that says this is what we expect, basically. So let's assert that current counter is equal to the initial count that we set up there. And then we need to give it a value to show if it fails. Great. So this is one way to do an assert. There's two different ways to do an assert. We can assert like this, or we can assert like this. This assert allows us to put longer data um, into the result. So it's a trade-off. It's a matter of preference. Preference are dependent on the test. But right now we'll just use the assert with the exclamation point and give it longer data so we don't have to worry about how long that string is. Okay.
We also would tend to remind the difference between a short string and a real string.
Yeah, so I believe when we do a short string, it's a fixed size. It has to fit into like what is it, I think one felt.
30,
Uh,
yeah, 31 characters maximum.
hmm So yeah, so there's two string types. There's that, and then there's the other type. I forget what that one's called. But
Byte array.
sorry, say that again.
Byte array.
Yeah, it's by the way. So um, that's the difference between the asserts. Let's see what happens when we run scarp test again. Great. So we can see that it passed. And just for an example, um, let's show a failure state. So if we failed in this test, then we will see that message that we've given it. Oh, well, this is a different one because I subtracted it. But if we do that, then we will see that message. So this was a different failure state, which we'll talk about testing that state in a little bit later. Yeah. Then we said count should be initial count. Great. So this is our first test. This is a great start. Now that we want to move on to adding more tests, let's modify this a little bit. So our first other test we're going to write, well, let's look. What should we write? We want to test the core behavior first. And this has three core functions: increase counter, decrease counter, and reset counter. So let's just start with increasing the counter. Let's write a simple test for increasing the counter. Now, when we're writing tests, an important thing in testing is that each test should stand by itself. No test should depend on another test. So what's going to end up happening is we're going to be writing a lot of the same code in our tests. For example, this test increase counter is also going to need to deploy the contract. So rather than doing all this deployment in here, let's actually move the deployment step into its own function. So let's call this deploy counter. And then let's basically just take all of this and put it in here. Okay, great.
Romania is asking, so in tests, when we deploy, we don't need constructor parameters?
We do have constructor parameters. They're right here. We serialize them and then we're calling them and then we're passing them to the constructor through this deploy function. So the constructor call data is the inputs to the constructor. We construct that from the inputs. So we have the initial count and we have the owner, which we can see we need here, the initial value and the owner. Okay. So now let's change this first one to use our deploy function. Um, but we don't always want our initial count to be 0. We're going to want to change this. So let's actually change this to a variable. Let me spell it. Okay. And the return type of this function for right now is going to be the iCounter dispatcher that we've created down here. Okay. Why is this yelling at us?
You need the arrow before the return type.
Arrow. Awesome. So this is our deploy function. So let's use that here. And we can call this dispatcher whatever we want. Um, I'm just going to call it counter. And we need to pass in an initial count. So in all of our tests, we'll just define an initial count um, and then pass it into our deploy function. Awesome. So let's make sure that's working. Great. So we can move on to this test. So we want to increase the counter. Let's just start from 0 again. Let's get our dispatcher. And now let's try and increase the count. So we can simply um, call counter dot increase counter. So this is going to call the increase counter function in our smart contract. And then we know that if we look at our contract, we can see that the counter should be incremented by 1. Okay. So our expected count is going to be the initial count plus 1. Now, I'm going to mention one thing here. I don't need to create this variable here and pass it in. And I don't need to create this expected count variable either, because I can just assert that the I can just get the count and I can assert it's equal to 0. But what this does is it makes it super, super clear what we're doing. And it makes our assert super, super clear. So now when we write our assert, we can simply say, well, first we got to get the current count. Just like we did in the previous test. Now our assert becomes very clear to anybody reading it what it's doing. Awesome. So expected count is initial count plus 1. We get the current count. We increment the counter, and we assert that that count is what we expect it to be. So let's see if that works. Fantastic. And now we'll just keep moving on. Now we do have some other behavior going on in here, but we're going to worry about that a little bit later. Let's actually just go ahead and move on to our test for decreasing the counter, and then we will improve those two tests together. Same thing. We're going to follow a very similar process. Um, Now, in the decrease example, we can see that if we go below 0, this is going to throw an error. So let's start at 1 so that we don't hit that for now. Because right now, we just want to test that when we call increase a counter, it decrements by 1. We will test this part a little bit later. Okay. So now we want to call decrease. This should be the initial count -1. And our message should say decrement. Great. Awesome. So
What
we
do
have,
you see that is the right message, the right error message?
sorry?
What did you see that that's the correct error message that you're comparing to? Oh no, you're not comparing. That's the error
No,
message of the
yeah,
assert. Yeah.
yeah,
Okay.
not
Sorry.
yet. Not yet.
Ahead of myself.
That will come soon. That will come soon. Yeah, so right where we're at right now is we have two very simple tests. These are testing, and testing, we call these very commonly happy paths. We are expecting this to happen. This is expected behavior. This is good. We're not testing an edge case. We're not testing uh, anything crazy. We're just saying, okay, I wrote a function that's going to increment, so I'm going to make sure it increments. Now, we want to move on to a little bit more complicated cases. So as we saw earlier, when I decreased below 0, we got a specific error that was an underflow. And through this error about the negative, if we call the decrease counter, it'll throw this error about it being a negative counter. Um, so let's improve our test to test that case. So in order to test failure cases, we're going to need to use something called a safe dispatcher, which we can see here. So what the safe dispatcher is going to do is um, it's going to let us catch that error and match on it and see what happened. So if it, as we can see here, if it panics, we can catch that and we can assert some stuff on it. So let's do that. First things first is we need to add this dispatcher. Right now we're only using the counter dispatcher, but we need to use the counter safe dispatcher as well. So let's change our deploy function to return both a regular dispatcher and safe dispatcher. Um, Set that up here. And let's call this dispatcher. And let's call this safe dispatcher. And now we can return these in a tuple. Excellent. Okay, so let's update our function here that gets the dispatcher. We're going to use the underscore to indicate that we're not using that. We're not using the safe dispatcher in that test.
Carlos is asking, what's the difference between the dispatcher and the safe dispatcher?
Yeah. So the dispatcher will not, the regular dispatcher will not catch that error. So the safe dispatcher lets us,
Increase the font size of that one.
yeah. So some like I'll just read this out. So sometimes we want to test contracts that can panic, like testing that a function verifies caller address um, panics on invalid addresses. So this will return a result rather than just panicking. And then what we can do is um, we can match on that result. So that's what we're going to do in the test. So let's write a new test for this specific case. Um, let's set our initial count to 0. And let's get our safe dispatcher. This time we're getting the safe dispatcher. So the first one is ignored. The first variable in the tuple is ignored. And now what we need to do is we need to match, rather than just calling counter.decrease counter, we're going to need to match on the result that is returned from calling that function.
We never talk about match. What is match doing?
Yeah, so match is going to we're going to get a result. So a result is either okay or it is an error state. So match is going to simply look at that and then do something based on what it is. So the first case is when it's okay. Um, and if it's okay, this is kind of counterintuitive. Um, this should return an error. So if it's okay, we're actually going to panic because this should have returned an error. So we're going to panic, which will cause our test to fail, and we're going to say overflow or underflow. Well, decrease below 0 did not panic. Okay. And now we need to look at the second branch of our result, which is when um, it's an error. So we get the panic data here, um, and then we're going to make an assert on our data that is returned, which is returned in an array. And so what are we going to see here? We have created an error state in this contract right here. And when we try to go below 0, then we should see this error negative counter, which means I should see this message. Awesome. So let's actually just grab that. Put it there. Okay. And this is an assert, so we still need Okay. And then remember when we do the long message in our assert, we need the exclamation point. Awesome. This is a bit long. I'm just going to run this cover format because it didn't happen automatically. Awesome.
Sandra is asking, the test can bring the failed 252 message by itself. Do we always need to add it in the test?
I'm not sure I understand what's been asked. The you repeat the question?
Basically, it's asking, do we have to always copy over the error message instead of bringing the failed over to the test and using like the module errors directly in the test instead of having to write the error message directly?
Oh, like because you assert that it through this negative counter error. Um, yeah, probably. This is one way to do it. Um, there may be different ways to do it. We could potentially assert that as this type, but for our cases, we're just going to well, this variable is a felt, and so I'm not sure.
Yeah, you
You
can, you can, you can, you can import that module error into the test and use the module directly if you want. It's just a matter of taste.
um, yeah, this is the way I'm going to be doing it. Okay, awesome. Um, and we should see that if we didn't throw that error, then we should see our message here. Okay, so in the case that we actually didn't go below 0, we'll see that message, but this is a correct test. Um, one other thing we need here actually is this feature, um, safe dispatcher, which I'm actually surprised that that ran. And Scarb, when they talk about in the docs, how we use this safe dispatcher trait. Um, but I'm not actually sure what this macro does. Let's see. Because it didn't seem to, okay. Yeah. So this safe dispatcher state is required, and we can put it in a number of different places. I'm putting it over the function I'm testing. Okay, great. Um, so let's move on to the increase state. So there's two different things that can happen when we're incrementing and we're decrementing. Um, when we're decrementing, if we go below 0, that's a problem. And then if we're incrementing, if we go above the max value that our count can hold, that's also a problem. So we can see that our counter is a type U32. So a U32 um, can only hold so much data. So if we increase above that, we will overflow the variable. So let's test that case as well. Actually, I'm just going to write this. So this is going to be a test. It uses the safe dispatcher. Well, actually, um, we don't when we go down below 0, we have a specific error case that's thrown. Um, when we are going to increase, we don't have a specific error. The error that's going to be thrown is actually a compiler error. So we don't need to necessarily assert that specific error data. What we can do instead is we can actually just use a different a different failure state in testing, which uh, is right here. So sometimes this is a desired behavior, um, and we can just assert that it should panic, and we can add this macro to just say that this should panic, and then we don't need to actually match on the result, and we don't need to use a safe dispatcher. So when we're going down, I'm just going to grab my little cheat code here. Um, we don't actually need to match. We can just say that this test should panic. So let's look at what's going on here. So we're setting the initial count to be this hexadecimal value. In hex, F is the largest. Each value is four bits. So two of these is a byte. So this is a 32-bit integer. So we need um, eight hexadecimal values to fill it all the way up. So we're filling all this all the way up so that when we increase by one, it's going to overflow. Um, Now let me remove this first just to see what happens. So this is going to panic. And we can see that what we got in the failure data is a U32 underscore add overflow. So we could use a safe dispatcher and match and assert that that is the error that was returned. Or because this is a compiler error that we don't need to necessarily assert that that is the specific error because that message might change. We can simply say that this should panic, and now the Foundry is expecting it to panic. So rather than that being a failing test, it should be a passing test. Awesome. Now we can see that success data there. Great. So we have some better edge case testing now. So let's look at how else we can improve our tests. So we have this function get counter, we have the function increase counter and decrease counter. We increment, and then we're also emitting an event in both of these. So we should test that. But we also have this reset counter function that we haven't tested all yet. So let's start there. Let's start with the reset counter function um, and add a test for that. So when we're resetting the counter, there's two different situations that can occur. If we look here, we're using this ownable.assert only owner. So we have this ownable component that is going to require that that function is called. This will panic if it is not called by the owner that we have set um, here in our constructor. So there's going to be two cases. We either call the reset counter function as an owner that we have defined, or we call it as somebody else. If we call it as somebody else, then this should panic, and if we call it as the owner, then it should actually reset. So let's test the first case where we're not an owner first. Now this case we are expecting to fail. So we're going to add our safe dispatcher feature, and we are going to get our safe dispatcher from the deploy function. And this time we don't need to do anything with the initial count, so let's just pass it indirectly. Okay, similar to how we did it before, we're going to match on the results of calling the reset counter function. Once again, if this is okay, then we actually want to panic and fail the test. And then when it is an error, we're going to need to assert something. So I'm not really sure what we should assert yet because we didn't define this. We didn't define this this error case. So one thing we can do, or one thing I like to do, um, is simply look at what the failure data was. I know it's not going to be an empty string. So in the failure data, I can just say, hey, let's show the panic data. So let's run this. Okay. So we saw that we failed with the message caller is not the owner. Let's go ahead and just copy that. Put it in there. That's what we want it to be. And now let's say that this should error if caller is not the owner.
Collins has a question. Why the asterisk before panic data?
We're dereferencing it. So we need to uh, get the data from where it actually is, if that makes sense. I think um, let's see, what is it called? It's a when we do the let's see, where's the yeah. So let me try to remember how there's reference and then we want to dereference. The at is what is the at? The at is the reference, I believe, and then
Snapshot.
say that again?
Snapshot. You're taking a snapshot.
Do you want to explain what that is? Okay.
You know what? I cannot explain it deeper than that. I just snapshot. I know what it does.
It's basically like
Ah,
a read-only version of a complex data type, right? And when you want to go to actually read one of the values, you have to use the dsnap operator. That is the asterisk that you're using. I'm gonna share the docs in the chat.
yeah, I'm about to drop the link now.
Yeah, this is this is a hard thing to explain verbally. You should look at some code examples to familiarize yourself with how this works. But yeah,
Yeah,
we need
the add symbol basically freeze in time the values of a particular data type that is read only, so you can, do whatever you want. You're not going to be modifying the underlying actual data type. It's like a safe way to interact with it without any risk of modifying or mutating the values.
yeah. And the asterisk is what is that? It's a
It's turning a snapshot into a regular variable.
yeah, there we go. So that we can use it. Awesome. So let's run our tests. Awesome. So we have now tested the case when we're not an owner. We see that it does not fail. And let's add another assert here that asserts um, that the initial count did not change. And the reason I'm doing this is because this will panic when we get to this line, but we might accidentally make a mistake and write it like this. So in this case, a non-owner actually will reset the state, and it'll still error, but the state will be reset. Um, so in that case, we should also have our test make sure that we don't make that mistake. Um, so we can also use our regular dispatcher because we don't want this one to have a result. And let's get the current count. No, we actually didn't need to change the initial count button. Um, so the current count should still be the initial count. If we look at the reset function, we see that this resets it just straight to 0. Okay, so let's run this test again. Okay, so that passed. But let's see what happens if we make the mistake I was talking about earlier. Awesome. So what this is doing is we're protecting ourselves from our own mistakes, basically. Because this is a really easy bug to miss. Because um, you might not think about it. And if you only test that this error message was thrown, it will still pass. Um, for example, this still passed, but our counter was reset. So that's very bad. So we want to make sure that we're testing for that case. Awesome. So like I mentioned, we have another case when we're calling the counter, and in that case, we actually are the owner. So we've set the owner here. So what we're going to do is we're going to use these little cheats. So Starknet Foundry calls these cheats. Basically, what this is going to do is it's going to let us change who's calling the function in our test. So let's create a new test.
Thomas, just so you know, we are 1 hour in, so anytime you want, we
Yeah.
can do the break.
I think we do. I think after this test, we'll do the break, and then we'll talk about the more advanced stuff with the events.
Sounds good.
Okay, so let's set our initial count. Let's get to 5. It doesn't really matter here. Let's grab our regular dispatcher from our deploy function. Let's call increase counter. And if I run this test right now, it'll fail. So what I actually need to do, well, if I do this, if I do counter dot reset counter, um, it will fail because we're going to hit this assert only owner. Um, so we need to call this as the owner. So what we can do is we can use our cheats. So let's start cheat caller address. So this is going to let us change who we're calling the function as. So we're going to say, and let's look at this function. So this function takes in the contract address, which is the contract that we're going to cheat, and then the caller address, which is what we want to set the caller address to. Awesome. So our contract address is going to be, we can get it from our dispatcher, and then we want to set the owner that we defined at the top of the file. Now, this is the only function that we need to change the owner, so we can go ahead and stop the cheat right there. We need to define uh, the same contract address. So if we look at here, this cancels the cheat. Um, and at that point, we're not cheating anymore, and the original caller is back. So if we look at the current counter, this should have reset back to 0. Awesome. Let's go ahead and run this. Cool. And we can see that that's test passed. If we don't use these cheats, then we're going to fail with the message that the caller is not the owner. And that is where we will stop for now. And then when we come back, then we can talk about how we want to test that these events were emitted.
I'm going to say that it's always a good practice to watch your test fail. That's where you know that it's actually working and it's not like a false positive. So what you're doing is actually good as a, pro tip.
Yeah. Pro tip, don't trust yourself. If you're making assumptions, you should verify them. I've shot myself in the foot many times by making assumptions that were wrong.
Yeah, me too, many times. All right, so we're gonna go for a break, 10 minutes, get your coffee and go to your bathroom break, whatever you need to do. Thomas, could you put a timer on the screen?
Sure.
Please, we'll be back in 10 minutes.
Okay. So where we left off is the last thing we want to do to improve our testing is we want to make sure these events were emitted. So to do that, let's look at the documentation. So there's a number of different ways to test contract internals. We're going to be using is this too small? Can everybody still see the text?
A bit bigger, one more. Good.
Um, so when we're spying for events, we can see this in the contract in the documentation here. Um, we can implement and test using this little spy events guy. So the spy events is going to let us look at the internals of what happens when we execute code in the contract. So the example that they have here is slightly different than how I'm going to do it. In this example, they're not actually deploying the contract. So you can using Starknet Foundry, you can write tests on contract state without actually deploying the contract. Um, but that is a little bit confusing and a little bit more than we need for this. So we could also just deploy the contract and assert events on it that way, rather than using this test address thing that they use here. Okay, so the way we're going to do that is with the spy events function. Let's look up at what we've used so far. Spy events. Well, we haven't yet used spy events, event insertion state, and the counter. So that's what we're going to use now. So let's look at our increase counter, and let's look at how we can modify this um, to assert that event as well. So like we saw in the documentation, we need this spy events. So let's set up our spy. Awesome. And now let's spy this event. Uh, so the function we're using is this assert emitted function. We can see that this takes in a list of events, a list of uh, tuples that contain the contract. Well, I say list. It's not Python. We're taking an array, the contract address, and then some event type. So let's do that. We can get the contract address from our dispatcher, and then the event type is from our contract. So let's look in here. We can see that we have these two structs for counter increased and counter decreased. And then we have this enum that contains those different events. Okay. Awesome. So this is the test for increasing the counter. So we want to make sure that we get the counter increased type. And we can look at our counter increased and we emit an event that contains the counter value. So if we look at when we call the increase counter function, we're going to emit this counter increased with the new count. So after it's been incremented. And that should be equal to the current counter.
You have to make it public.
Oh, no, it's I'm reading off the wrong thing. So we changed this to Starknet workshop counter. Uh, oh, you're probably right, actually. It probably does need to be public. So let's see what's going on here. Counter increased is not visible in this context. And counter is not visible in this context either. So let's look at our contract. So to get the counter, that also needs to be public. And then the struct needs to be public as well. We're going to need to do this for the decrease state, so I'll just do that right now. And we can see that this is yelling at us because it needs to be mutable. So let's add mutable there. Awesome. Now let's see what happens when we run this test. Great. So that passed. But what if the current count is wrong? What happens if our test fails? So let's see. So if the data is wrong, we see some different failure data, and it tells us that the event with matching keys and with matching data and keys was not emitted. So the matching data is that current count. Awesome. So when we decrease the counter, this counter decreased event is emitted as well. So let's go ahead and add this logic to our test for decreasing as well. And so we make sure that the decrease event is also emitted. We need our spy events variable as well. And then this is going to be counter decreased. And it should still be the current count. Awesome. So now we have a whole test suite for our contract. We're testing everything that's happening, both our happy paths and our sad paths. Happy paths being the paths that we expect, and sad paths being the edge cases and errors that could occur. And we're also testing our contract internals and making sure that the events are emitted, and we are protecting ourselves from accidentally doing things in the wrong order um, by making sure that our tests account for the order that we're calling this panic in. And that about wraps up what we're going to cover.
Okay, awesome. Make sure you guys ask any question you have before we go to the quiz. So let's give it 5 minutes before we launch the quiz.
Yeah.
But yeah, that's how you test a smart contract using Foundry.
Yeah, that's Starknet Foundry.
I use test a lot especially for a smart contract just because it gives me the very fast feedback loop that I'm doing the right thing instead of having to compile, declare, deploy, and then go to some kind of UI to manually interact. That will be too slow to do, on a regular basis. So testing is a great way to short circuit that whole feedback loop. And it's much more robust because it's automatic.
Yeah. Yes, it reduces the size of the bug. That's a really good point. Let's say you have some like massive function that's doing a whole bunch of things. Yeah, minimize future refactoring. You can break out each of those little like you can um, take each of the logical steps that's happening inside of those functions, break each of those logical steps into its own test, and that way, um, you know which parts of your function are succeeding and working as expected, and you know which parts are not. So yeah, great call out on that, Casey.
Segun has a question from the last class. Feel free to ask a question. We have some time to help you out. If Annie is saying it helped write clean code, and reduce the number of code to write.
Yes,
Okay, if there are no more questions, sorry, go ahead.
oh, I was gonna say, it might be. A lot of people think that when you start doing like test-driven development and writing tests as you go, that it'll slow you down. A lot of times people are like, "Oh, I just want to write the contract and then um, get it out, and I don't want to, waste time on tests." But in the long run, especially when your projects get more complex, tests will actually speed up the your development time a great deal because your code is not going to stay static. You might have one function or one contract that you've deployed and you've tested manually. But as soon as you need to refactor that, you could be writing bugs and you might not even know it. So if you don't have tests, you can shoot yourself in the foot when you start refactoring.
Question from Romain. How do we access an array that is in storage?
Uh, like in testing or in let's see.
Yeah, if you get more specific, Romain. Yeah, he's saying in testing.
Yeah, I think this would work. If it is simple. Yeah, so they have this topic on direct storage access. So these are cheat codes. So similar to how we did the start caller address cheat code and stop caller address cheat code. Um, we can use these cheat codes to um, also access storage.
That's all for today. Uh, Take a look, check it out. Thank you, Thomas, so much for the session today. It was very informative. All the different type of test strategies, tools, scenarios. Uh, Next session, we're gonna have the last session for front end. We're gonna build the front end of this app that we're building, a simple counter smart contract. As always, thank you very much for your attendance. Any questions you will have, go to Discord. We're there to help you as well, and we will share all the links as well there. Have a good night. Thank you very much.
Thanks, guys.